Hello, Geography 232 students. How's everybody doing this evening, or this afternoon, or this morning, whenever you might be doing this? Hope you're all doing well. Hopefully, you are all staying sane and staying safe during the lockdown. Um, let's see, this is week 13. We are going to be continuing on into the getting to know Model Builder textbook. So, last week we took a bit of a detour and got into Python scripting. And you'll see this week why I sent you on the detour, because this week's lab relies on quite a bit of Python scripting once you get into sections 3D, 3E. So yeah, I wanted to make sure everyone had, I think, a proper foundation to pursue Python. In this textbook, I mean, when we do get into Python, it's very much step by step laid out fairly clearly for you. So it doesn't expect you to know anything or to have any sort of prerequisite knowledge of Python programming. So even if we hadn't done last week's module, I think you would have gotten by all right, but I don't think you would have understood it quite as well. So I hope that the reading and the tutorial and the labs from week 12 proved fruitful and useful, and you were able to take plenty away from that, and hopefully beyond this class be able to kind of increase your Python skills, because Python is it's a very useful programming language to use, or to know rather, and really just knowing any programming language is beneficial because you can often jump from one to another. But Python itself is a fairly straightforward, and some would say easy programming language. I would never say it's easy just because it's not my forte. I it's not my area of expertise, although I know a bit, but I would say I'm like a second grader compared to a high school student when it comes to my Python knowledge. So for you all just starting out in the GIS world, I definitely recommend further pursuing Python, because it's very useful not just in the GIS world, but in data, big data, data science field. So if you have an interest in data science, which is definitely a growing, burgeoning field out there, Python is definitely a good one to know. So, all right, let's get into announcements real quick before we get into this week's tutorial. Zoom meeting. So I mentioned last week that if you wanted to set up a Zoom meeting, I'd be happy to facilitate that with you. And several of you have taken me up on that offer, so that was great. Had very fruitful conversations over the past week with students. And so if you would like to chat about your projects or just about weekly lab work or anything, just send me an email, let me know, and I will definitely send you a Zoom invite and set that up. My only stipulation there is that I want to limit our Zoom meetings to Monday, Wednesday, 6:30 to 9, so our normal class hours, just to kind of keep a separation between my day job and our classes. So that's my plan. So if for whatever reason those times don't work for you, let me know. We'll work something out. But ideally, my preference is to keep it during our regular class hours. Next announcement, I want to just remind everybody that our presentations are under a month away. So for our presentations, we're going to be doing a class-wide Zoom session. So I will send out an invitation to you all closer to the date. You just have to accept it. And then when the time comes, log on to Zoom. We'll have a shared Zoom chat room essentially. And I want to make sure everyone, hopefully you all have webcams, because I want to be able to see you guys. But beyond that, the more important thing is being able to just do a screen share, which is easy to do with Zoom. So basically what you'll do is prepare a PowerPoint presentation on your own. It doesn't have to be PowerPoint, it could be Google Slides, or there are several different ways to do it. But obviously PowerPoint's the most common way to present slides. So do that. Then you'll just do a screen share and you'll share your presentation with your classmates. So just prepare for about 5 to 10 minutes each, with an additional 5 minutes of question and answer. As far as the actual schedule of events, I'm hoping we can do it all in one night. But if we have to go over to 2 nights, then we'll do it on Monday and then again on Wednesday. I'm going to schedule students alphabetically. So if you've got an A or B last name, you'll go toward the front of the night. And if you ladder in the alphabet, you'll go toward the end. If, however, you have a ladder alphabet last name and you want to go early, that's fine too. Let me know. I'll take special requests as far as going earlier, just not going later. I will send out emails to students just to get a head count in about a week or two, just to make sure that you still will be presenting. I know some students have kind of disappeared into the ether. Not too many of you, fortunately, but a couple. So make sure that obviously if you are still participating, make sure you're turning in work. But I'm going to send out emails to everyone just to say, hey, can I count on you to be presenting? So just let me know, and I'll also ask if you have any preference in terms of the order of the evening where you want to go. All right, so let's see, Q&A. Yeah, final essays, and your final map products, whether it's going to be a PDF or a web map or something like that. You'll need your essay and your map on Canvas by Wednesday, May 20th at 9 o'clock p.m. So basically, the very last day you can submit it is our Wednesday class period of finals week. So May 20th, Wednesday, May 20th at 9 o'clock. So there already are spots on Canvas for those assignments, but just make sure you have those on. Late work will not be accepted. So, if you have a last minute issue, send me an email in advance. But if I get an email from you after 9 o'clock on May 20th, I'm sorry. That means the ship has sailed. So make sure you get your work in on time. Last announcement before we proceed. This week's lab, well, it's not really an announcement, I already kind of mentioned it. It incorporates a bit of Python programming, which we already have talked about. So just make sure you follow the steps step by step. I would say it lays out in fairly clear detail, and it really kind of is, it's very hand-holding, if you will. So it doesn't expect you to know anything in advance. So you just basically make sure you follow the steps. Python is case sensitive, so make sure that you are following whether it's uppercase or lowercase. And if you get stuck at any point, I've mentioned this, I think, in other announcements, but there is an errata document, basically errors that exist in the textbook or changes that have been prompted by changes to the software. So like as the software is updated over the last few years, there are various steps in the textbook that no longer make sense because whatever that step was relying on a tool or whatever it was, if it's changed with the software updates, you might run into some sort of a dead end. So there's an errata document that I've uploaded to Canvas, and I've linked to it in several different places, and basically it accounts for all the errors that you may find, hopefully any errors that you'll find. And so I'm going to include each of the pages where an error has been found and documented in the errata document, and I will include that in this week's announcements. So you'll have it there, but it's I definitely recommend downloading that document so that if you run into an issue, instead of having to email or post on the message board or email a classmate, just first, before you do that, check the errata document because it may already be answered in that location. Okay. Without any more further ado, let's proceed to this week's tutorial. So we are now in chapter 3 of Getting to Know Model Builder. This chapter is called Establishing Flow of Control. Essentially what the goal of these next two chapters are, chapter 3 and chapter 4, is to basically fine-tune the automation steps and processes that can be done with Model Builder. So in chapters 1 and 2, we created fairly linear models that basically have a start point and an end point and had no real chance to diverge, to never, there are no chances of hitting a roadblock or a chance of hitting a fork in the road and having a yes or a no kind of situation. They're all very linear. What chapter 3 and chapter 4 are going to do is allow you to explore how you can actually increase the complexity of your models by allowing for variables that may throw a wrench in. Like, let's say, for example, if a feature class exists, proceed. If a feature class does not exist, stop. All right, so there are if and elif and then type statements. So just be aware that that's essentially what we'll be doing next, is getting a little deeper, a little more complicated into the workflow of a model. I'll be doing exercises 3A and 3B with you, and then you'll do 3C, 3D, and 3E on your own. 3A and B that we'll be doing in this tutorial do not include any Python. You'll be introduced to Python in 3C and really get into it in 3D. And so just be aware of that. I will not be going over any Python in this particular tutorial, but as I mentioned before, it is fairly straightforward, and just follow the steps. Make sure you pay attention to your keystrokes, and proof your work if you run into any issues. To go back and just do a quick proofread of your Python script if you have any crashing or errors or anything. So, okay, so
if the ArcGIS Model Builder application is to function as a visual programming tool, it must be able to essentially function like most programming languages do. So one of the things that programming languages do is they allow you to manage and input various variables. We were introduced to variables in the last chapter, chapter 2. And also, it has to allow you to control the order in which different processes are evaluated and run. And that's what we're going to be focusing on now. So as I mentioned before, in chapters 1 and 2, the models were very linear. From start to finish, there were no real forks in the road. We're going to introduce some forks, so to speak. So that's what we'll be doing. Basically, this allows your model to make decisions, essentially, based off of inputs. Okay. As models get more complicated, we tend to have more tools involved, more input variables, more output locations, and so on and so forth. As they get more complicated, it's up to you, the model builder, designer, to set various preconditions that must be set. So precondition is a new term that I'll talk about in the lecture notes. Essentially, a precondition is a prerequisite step that must first be accomplished before the remainder of the model can run. Basically saying, before we can proceed on to, let's say, creating a new feature class, we first must find out what are the input types, what are the input geometries, is it going to be point, line, or polygon? So preconditions essentially set the groundwork for the remainder of the model to run, all right? So that's what we'll be doing coming up shortly. Let's go ahead and open up MXD EX03A or exercise 3A. I already have it open on my screen, which hopefully you can already see. And make sure that you copy the toolbox called Chapter 3A from the sample models folder. So go ahead and right-click 3A. I've actually already done it. I should have mine already over here. 3A. Then you're going to want to go ahead and open up the toolbox. And notice we have the Create Oleander FC or feature class model there. So let's start by editing the model. Right-click and edit. And then we are going to have basically two different tools, Create Feature Dataset tool and Create Feature Class tool, that are in the not ready to run state at this moment. In order to get them in the right state, we're going to have to add a couple of variables and set a few parameters. So on the Model Builder toolbar, we are going to click on Insert, Create Variable, and then we're going to look for the workspace variable. So scroll down, alphabetical order, workspace. Okay. And this will generate the Geodatabase where the new feature dataset will be created. So a feature dataset, I was defined that in my Intro to GIS class as a file folder. Within a file folder, I think of the Geodatabase as a file cabinet. A feature dataset is a file folder within that cabinet, and then feature classes as individual files within the folder. Okay, so we're going to create a new file folder and a new file to go within that cabinet, which is the Geodatabase. So go ahead and click on the new variable workspace, double click, and we're going to set the output location to the results geodatabase, which is the geodatabase in which we've been saving all of our data so far. So it should be basically under the GTK model builder, my answers results.geodatabase. Go ahead and click add, and then OK. All right, so now we've got a independent variable here hanging out off to the side, and we're eventually going to be connecting that to the feature dataset creator and the feature class creator. So now we're going to create another standalone variable. So once again, insert, create variable, and this one is going to be called string. So a string, as you hopefully recall, is just a string of text, a text string. Go ahead and hit OK. Move it over here. And let's rename it new FDS, new feature dataset. New FDS, feature dataset. Okay. All right, go ahead and double click the new FDS variable. And let's type in new feature data set. And what that is essentially a prompt. So once this model is run, that prompt will show up as new feature data set and allow the user to input the name of that new feature data set. All right, notice it turns light blue. It's now in its ready to run state there, but obviously it still needs to be connected with the rest of the model. So we'll do that. Next, we're going to create the last standalone variable with another data type of string. So once again, insert, create variable, scroll down to string. If I can find it, there we go. Okay, and move that down below. And let's call this new FC, new feature class. And rename new FC. So we've got new feature data set and new feature class. And then the last thing we're going to do with new feature class is double click it. And again, change that prompt to new feature class so that when the model is run, there's a prompt there to say, what is the new feature class going to be called? Go ahead and hit OK. So now we have 3 there that are ready to be connected to the rest of the model. Next thing we're going to do is double click the Create Feature Dataset tool and set the location to the results geodatabase, results.gdb. Notice the blue recycle icon there next to the dataset. It indicates that this value is coming from the variables already contained in the model. That means that it basically exists in theory. It exists in a state that it's not a hard location at this point, but it knows it will eventually exist once the model runs. So you can already choose it as an output location. Okay. For the data set, we are going to use the variable, the %, which is like the wildcard variable. Okay. New FDS %. And that essentially is a substitution variable. So it will substitute that new FDS for whatever the feature class name will eventually be once it's input by the user. Okay. The third and final step here, and here is actually an errata step. So if you look in the errata document, it'll say at I think step 11 on page whatever it is 104 that the instructions are a little bit different, and basically the only difference is that the software has changed a bit so that now you can have favorites when it comes to coordinate systems. So in the original text, it tells you to import the projection coordinate system from another feature class, but actually all you need to do is just hit that browse button. Then in the favorites, which are already chosen there, you've got NAD 1983, State Plane, Texas North Central. That's the one you want. Go ahead and hit OK. So it's actually just become much faster and easier. Then hit OK again. But on that note, just be sure to download the errata document. It's on Canvas, as I said, and just kind of have it open in Acrobat as you're working your way through the PDF, the textbook PDF, and so you can switch back and forth. Now, obviously, you would have been able to figure it out by importing it from another feature class, as the instructions say. But if you do run into any kind of like work stoppages, it's just easier to have that errata document there to kind of smooth the transition. So let's rename the new FDS output to created FDS, as the text says, created DS. All right, and then let's save your model. Now's a good time to save. Okay. All right, so several things happened when you set the parameters for the Create Feature Dataset tool. A connector line was added to link the geodatabase to the parameter for the tool. So you can see now results.gdb is now connected to the Create Feature Dataset tool. All right. You still have to essentially, the rest of the tool, the rest of the model rather, is not in the ready to run state yet, but this first step is. So the create feature dataset and the output feature dataset are in the ready to run state, but obviously, as we can tell, these are still white, so we still need to complete the rest of this model. All right. So in order to do that, let's double click on the create feature class tool. And then we're going to set the feature class location to created FDS. And once again, you'll see the blue recycling sign. And that's because even though this location doesn't exist yet, or the input data doesn't exist yet, it will exist. And based off of the format of this model, we know that it's going to be there so that when it exists, we can plug it right into the next step. All right. For the
feature class name. We're going to use that substitution variable again. So the %, new FC, and that will be replaced by whatever the new feature class input is by the user. And then do not overlook this step. The geometry type is point. So the default is polygon. Make sure we change it to point. And then we're going to import the template schema from the accident schema layer, import the template feature class from the accident schema layer like we've done in previous labs. Just go ahead and do OK. And everything else should be fine. So go ahead and click OK to finish that. Now we notice our model is looking a little messy. So if your model starts to look messy, you can obviously drag them around by hand, but I recommend using the auto layout button instead. It's these little there's 2 blue and 2 green boxes here. Click that button and it will do an auto layout. So put them in order, and then if it goes off screen there, just hit full extent. And then, so if you do that, yours should look the same as mine at this point. Okay, so always rely on this auto layout button, as it will help you as your models get bigger and more complex, and that will happen. Okay. All right. So next thing we want to do, right-click the feature class tool. The create feature class tool, and go to properties. So here's the first time you're introduced to preconditions. So I mentioned before, a precondition essentially is a prerequisite that says that X, Y, and Z must be completed before this step. Right? So it basically puts this particular step in the model after the precondition of, in this case, created feature dataset. So first we have to create the feature dataset, which is the file folder, right? So you have to create the file folder before we can create the file to go into the folder. So I think that's the best way to kind of envision that. Go ahead and hit OK after you've clicked Create FDS. And now click the center of the connector line between the created FDS variable and the Create Feature Class tool. So created FDS and Create Feature Class. It's right here on my screen, and kind of drag it out a little bit. Notice how we have this second arrow or line and arrow. So we've got the main one and we have a second one here. So the second line and arrow tells you that this is a precondition. This is the variable that must exist before the tool can run. Okay, so that's how you know that a precondition now has been created. You'll have this dotted line, this light blue dotted line from created FDS to create feature class. All right, so go ahead and save your model. All right, so you probably noticed there's a little bit of discontinuity there. I had to change something real quick. Okay, so one step I forgot to mention as I was going through here was the parameter setting, the new feature class and the new feature data set as parameter, as parameters, model parameters. So I somehow zoomed right past those steps as I was going through the text. I should not have done that, so I apologize, but hopefully you were not confused as I just skipped over those steps before. So before we move on, make sure you right-click on New FC, make it a model parameter, make sure there's a checkbox there, and then do the same thing for New FDS, New Feature Dataset. Make sure it's a model parameter. Then go ahead and save your model, close your model, and then double-click it to run. So double-click. So for the new feature class, we're going to call the feature class PD3344 underscore. So PD underscore 3344. For the new feature data set, the new FDS, let's call it your name. Okay, call it your name. My name is Ian. Your name is whomever you are who's listening to this. All right, then go ahead and hit OK. Let it run. And notice how I just minimized the results geodatabase. Now I'm going to maximize it again, and there should be a new feature data set in there. If I refresh, hopefully. There we go, called Ian. And then within Ian, there is PD3344. So it was successfully created. Okay, so that's exactly what we want to see. So the preconditions that we mentioned, the preconditions ensures that the feature data set is created before an attempt is made to create a new feature class. And so luckily, the feature data set called Ian was created before the feature class PD3344 was created, because if we'd done that, there would have been, if we'd done it in the reverse order, then the PD344 would have still been created, but it would not have been placed inside of the feature data set. Okay, so that's why you want to put them in the correct order. All right, so that concludes exercise 3A. We're just going to press on to exercise 3B now. Exercise 3B is called using if, elif, else statements. So basically, this allows Model Builder to make decisions, evaluate input data, and then make a decision whether to proceed or stop in this case. All right, so that's what we're going to be doing. There are a handful of what are known as model-only tools that can be used to basically allow Model Builder to make decisions, if you will, which it's going to be doing. And so without further ado, let's proceed on to 3B. So we can go ahead and open up the MXD. You can save your work if you want. I'm not going to. Then once again, just like with 3A, make sure that you copy and paste the toolbox, the appropriate toolbox, in this case 3B, from the sample models folder, copy it, and then paste it into the My Answers folder. All right, so I've already done it. Mine's right here, 3B, and within it is the PublicWorks Notify tool. Okay. Once again, as I mentioned before, there are several steps where the errata document will come in handy. Primarily in this case here, this chapter, it's just replacing images from the text with more up-to-date images that would be what you will be seeing and what I'll be seeing in the tutorial. Because again, the text was published in early 2010s, rather. I think it was published in 2011. And so the software has gone through several updates since then. So just be aware of that. If you see there's this sort of lack of continuity, it's because the imagery reflects an older version of the software. So just pick up that errata document and have it, like I said, side by side with your textbook as you're working your way through. Okay, so we've got the MXD for 3B open. We've got our toolbox pasted into the My Answers folder. So let's proceed. So to see what happens when we run this model, let's just go ahead and double click it and we will find out. So before we actually even know what this is all about, we're going to go ahead and run. But just so you know, step 2 of 3B is an errata step. So to tell you guys what that is, I'm going to find that here. So essentially all it is that the interface in the image of the interface in the textbook looks different than the interface you're seeing. So you should be seeing, let me just pull up my document so you can see on the screen. You should be seeing a tool that looks like this, which is what I see too and what you see in the tutorial, but it's not what you see on the page of the textbook. Okay, here's what you see on the textbook. That's wrong. This is what you are seeing now. Okay, so don't get confused. It's okay. It's really just that things have changed a bit since the software was published. Excuse me, since the book was published, and just pull up that errata document. So what we will be doing instead is leaving the first step as is, and then entering empty underscore output table. And the name gives it away. It will be an empty output table. So go ahead and hit OK. Notice here in the basically the transcript of what went down with the model in the background, you see this green text. It says here, warning, empty output generated. Well, we ended up with a table here in our contents pane, so let's check it out. Not much of a mystery here. Sure enough, it's empty. Okay, so what this model should have done, if you remember from chapter 2, is select the adjacent parcels to the street, but there was no street selected, therefore there were no parcels selected. Well, in this scenario in the textbook, basically the idea is that if you are designing software for, say, a staff of planners or police department, whomever, they're not going to want to run a model or a tool that's going to result in an empty table. It would be better to be told in advance, hey, there is nothing selected, the outputs will be empty, do you want to proceed? And so that's what we're going to essentially create is one of these steps in the model that will allow the model to stop running if there are no features selected. Okay. So let's see, we've reviewed that. Okay, so let's go ahead and start editing the model. Right click, edit. And notice it's already quite a bit more advanced than the previous exercise, quite a bit larger. So I won't even go over everything, but it should be a little familiar from chapter 2
It's just a little bit more in depth at this point. Okay, so um, we actually need to add a couple of tools in here to start to build it out. So first thing we're going to do is click on the search tab. If you don't already have the search tab open, you just click on the search button up there. It looks like a little globe over a window. And we're going to do a search for get count. There's a tool called get count, which will get a count of how many features are selected. We're just going to drag and drop that right into our model. Kind of move it over to the left a bit, okay? And then for the next tool, it's not in the, you wouldn't find it via search, it's actually a model-only tool. So insert model-only tools, then calculate value. All right, move that down there. And then for the third tool, repeat that process, insert model-only tools, and find the stop tool. So as the name implies with the stop tool, it allows the model to stop if certain preconditions are not met. Okay. All right. So we are going to connect the calculate value tool to the stop tool. So use the connect tool. All right. So we will draw a line between output value and stop. And then it'll ask you based on what? Based on the input values. So whatever the input values are into the stop tool, that's what will determine whether it stops or not. Okay. Next, we're going to use the connect tool again to connect the street center line selection, which is this oval right here, street center line selection. Connect that to the get count tool. Okay. So go ahead and draw a line with the connect tool from street center line selection to get count. Once again, based off of input rows. So again, it's based off the input. Okay. Now the next step relies on some Python programming. So we did our Python training in ArcGIS Pro, but the concepts are exactly the same. The only difference doing Python programming in Pro versus ArcMap is just the interface. It's a little bit different, a little clunkier, but it works essentially the same. So don't be daunted by a new program in which to practice your Python. It's actually an old program. It's just that we haven't used it yet. So essentially, what you're going to do is just on page 116, you're basically literally just going to copy all of the text that you see there, including the number signs or the hashtag signs there. So if you think back to last week's Python lesson, you'll know that the hashtag sign or the number sign is it tells the script that the following text is commentary or it's comment. It's not part of the actual script itself. So if you see like on page 116, step 7, you'll see number sign or hashtag space define a function to accept the input. What that does is it's describing what the next step will be. You're defining a function to accept an input. Then indent 2 spaces and add the if statement. You literally will then do that. You add 2 spaces. So that's a key thing as well, is that in this particular block Python block builder here, it doesn't indent automatically. When you're in a block of text, like it often does in ArcGIS Pro or even in ArcMap if you're in a text editor, it doesn't automatically indent your text when you're building a block of script. So you have to do it yourself. So to start the prompt, you do 2 spaces. Then to continue that block, you do 4 spaces. This is documented here in the textbook itself, but just be aware of that. So at any rate, we're going to now double click the calculate value tool. Make sure you switch back to this select tool here before you double click, or else you'll still have the connect tool selected. So make sure you do select. Now double click on calculate values. And now, luckily for you all, you don't need to watch me type it all in because I already have the text here saved. So I'm just going to copy and paste over. But now would be a good time for you to start typing it because it's quite a bit of text. And yeah, definitely do still include the comment lines as well, just to remind you what it is that you're actually doing. Okay, so node indentation. Then for the first block here, we have 2 spaces. Then the continuation of the block, we have 4. 1, 2, 3, 4. Okay, and go ahead and hit OK when you're ready to go. But here's something that you need to know. In order to use the calculate values and the stop tool, you first have to run the calculate value. The stop is based on a Boolean um, value of true or false, or yes or no. Okay, and so in order to have an answer yes or no, you first have to come up with a value. The value is, are there any features selected? At this point, it's no. And so once the stop tool gets that no or that false, it'll know to tell the rest of the model to stop running. So long story short, you just right click on calculate values and run it. Okay, it's run. Now on my screen, you'll see here value equals false. That's the key detail that now gets fed into the stop tool. Okay, so if it is false, if the value is rather 0, then you'll get a false, and then it will stop. If it's anything but 0, if it's over 0, then it'll be true, and it will not stop. Okay, so be aware of that step. Next up, we're going to double click the stop tool and then set the stop when inputs are false. Okay, so if the input is false, that means that no features are selected, then it tells the model to stop. That's basically all it comes down to. It's just the Boolean true or false, yes or no, 1 or 0. Okay, go ahead and hit OK. So now the stop model tool is set. Finally, there are 2 preconditions to set to make sure that the tools run in the proper order. The first is a precondition set on the calculate value tool so that it runs after the get count tool. And the second is a precondition set on the select layer by location, parentheses 2, so it's the second one, to make sure that doesn't run until the stop command determines the features are selected. So essentially, you can kind of envision this model running as you've got the inputs, they get selected, it goes on to the street centerline selection. If there are no, then it has to get a count. It gets a count of the centerline selection. If there are no streets selected, it will stop the model. If, however, there are streets selected, it loops back and continues on. Okay, so we're going to kind of visualize that here shortly. So go ahead and open the properties for the select layer by location 2 tool. Go to properties. And then click on the preconditions tab. Mine's already up, and select continue. Okay, and then hit OK. And now notice how it loops back around. Okay, so if the stop tool gets a true, then it will continue on. If it gets a false, it will stop. So kind of think of this as a stop sign. If all the preconditions are met, the model continues. If they are not, then the model stops. Okay, so now let's open the properties for the calculate values tool and set the precondition to row count. So this essentially is saying that first, before we calculate the values, we have to get a count. We have to get a count of how many, in this case here, rows are selected. So first we have to get the row count, then we can calculate the values. Once the values are calculated, if it's more than 0, continue on. If it's not, it hits the stop sign. Okay. All right, now go ahead and save your model and close it. And now we will, you can sort of, hold on a second. Yeah, we're going to run the tool again. And we ran when we first started. We're going to run the tool, but because there are no roads selected, we're going to end up with the same result. But let's go ahead and go back to catalog, double click the model. For the output, let's call it empty output table 2. And we know it's going to be empty because no streets are selected. But go ahead and give it a run. Now know what happened this time. Okay, so previously we ended up with an output table, right? An empty output table. In this case, there's no empty output table 2 here. Why is that? Well, because our stop sign worked, right? Our stop model tool stopped it. So all inputs, let's see, let me find the appropriate step here. The process did not execute because the precondition is false. That means that the precondition had to be that there were some streets selected. No streets were selected, therefore it received a false. The false told the model to stop, and it did. So we didn't end up with any empty tables. Okay, so go ahead and close that out. So we know that our stop sign has done the trick. All right, but now let's see if it actually works if we do have some features selected. So let's go ahead and do that. Let's run the model once again. All right, this time use the feature set template. Go ahead and click on that, and then draw a line along Peterstowe Drive, which is this street here on the south end of this neighborhood. You just go ahead and draw. Oops, I guess you have to click. Draw there, and then double click to end it. Okay, so we've got that selected. Oops, hopefully that's done. F2. Okay, there we go. Now let's change the output name of this table to Peterstowe, named after the street, and go ahead and hit OK. All right, it's run, it's completed, and now we have an output table here called Peterstowe, and there should be X number of features, 32. So 32 features within the Peterstowe data table. Okay, so that's essentially how we do it. So we essentially built the model. We put in the if, elif, else statement to say that if this precondition is met, continue. If the precondition is not met, stop. And it did stop. And then we ran it again with the selected street, and it ran. So that's exactly what you want it to do. All right. Do note that there on step 14 that we just went through, page 119, there is an errata step as well. Once again, the errata is referring to the image. The image has changed. It looks different in ArcMap now than it did when the book was published. So don't get thrown off by step 14 on page 119. Just pull up the errata document, check it out, and it will just walk you through it. But essentially, it's pretty self-explanatory if you could get through it without the errata, but it is nice to have that just to take away any sort of questions. So, all right, so that concludes this week's tutorial. Continue on to exercises 3C, 3D, and 3E. And I will have a description of what I need from you as in terms of a product to turn in onto Canvas shortly. So I'll have that on Canvas to kind of explain what I'm looking for. So goodbye for now. Have a good night, and I will talk to you all next week for, I think, our final lecture in lab. Week after next is going to be what we would have had as a open lab to work on your projects. What that translates to, now that we're working remotely, is just that you'll just have a week to work on projects. Obviously, no lab time. But as I mentioned before, feel free to email me with questions. We can set up Zoom meetings if you want. I'm here to help, obviously. So take care. Have a good night.